Hey guys, and welcome back. It's Mr. Cole, the Alabama Science and Motion Physics Specialist working out of Jacksonville State University. I'm bringing you a lab today. It's known as Motion on an Incline. And essentially all we're doing today in this lab is this. We're going to watch the motion of a cart as it rolls down an incline plane. So behind me I've got a 1.2 meter long dynamics track. At one end this is known as a motion sensor. And what I'm going to do is this. I'm going to take this cart, place it on the track about 20 centimeters from the sensor, and I'm just going to release it. Let it bounce once and bounce twice. And that's when I'll stop and record my data at that point. Now, the motion sensor, if you haven't seen one in one of the other videos, is really kind of neat. It works like the depth finder on a fishing boat. It actually emits a sound wave, and you can hear them in person. You can hear them making that clicking sound. And that sound wave bounces off the end of the cart, and by that it's able to use echolocation, kind of like the way a bat's able to see in the dark. It uses echolocation. Although does a bat really see in the dark? It's using sound waves. Crazy, right? So what it's able to do is, by using the echolocation, it bounces the sound wave off the back of the cart, and therefore the computer is able to tell you the position of the cart, the velocity, and the acceleration of the cart. Now, one of the things that sometimes confuses people in this lab is they're like, well, the cart's rolling downhill, so that's negative. Time out, stop. The way the sensor works, anything moving away from the sensor is given a positive value, while anything coming towards the sensor is given a negative value. So as you do a pre-lab, you need to keep that in mind. So what I want you to do is this. You'll notice in your lab that there are three graphs, just like the position, velocity, and acceleration graph behind me given. What you need to do at this moment is make a prediction and try and really think about this ahead of time. What do you think the position, velocity, and acceleration graphs will look like? So I'm going to give you a hint. What should be the initial velocity of this object? Well, let's look at it. Well, it's just kind of sitting there. So what we're going to do is release it, allow it to bounce once, bounce twice, and then I'll hit stop. So what I want you to do is this, and then we'll take this data for real. Go ahead, make a prediction based upon what you've done in lab already as to what you think these graphs will look like, and then we'll move into the rest of the activity where we'll actually mash record on the software, and we'll get a printout of these, and you'll begin to do your analysis of those. So here we go, guys. So hopefully at this point you've made your prediction. So let's go ahead and click record on the software, and I'm going to release this cart and allow it to roll down the incline. So let's see what happens. And there it goes. So what we've got, and I'm going to do something. I'm going to maximize this so we can see a little bigger, and it's still bouncing in the background. But you can see how it started out, though, with 0 for a velocity. And I tried to give you that hint in the earlier portion of the video. And then you can see how it did start increasing with a larger and larger positive velocity. And then the most interesting thing happens when it strikes the end. You can see this change. It went from this maximum positive velocity all the way now to what appears a maximum. This is the part everybody messes up. A lot of people will actually do this sawtooth, but they don't think about the fact of what's going on in this portion right at this spot. And so now you can see it when it bounces back up the hill, it has this velocity, but it's this big negative velocity because it's moving the opposite direction. And then it's kind of interesting what happens through here. What you're going to be asked to do now is your teacher will provide you with a copy of this graph, or you may even have to just look at some pictures of graphs in the remainder of this video and pause on one of them. There'll be 5 different graphs that on the end of this video. It's a whole lot easier to do this lab when you can get a ruler out or something and print the graph and look at it by hand, and hopefully you'll have access to that. But right now, that's just the thing. We don't necessarily have access to everything we'd normally be able to do. But you'll be able to look at these graphs, and you're going to try and figure out some of the details of what's going on. So you're going to mark on the graph and be asked questions from the graph. So let's take a moment, and your teacher may assign you this, or you may need this section of the video just to help, but your teacher may want you to actually gather data from this data run that we've got in front of us. So I want you to look at something. This is right before I let go of the cart. So if you look, my velocity is 0, my acceleration is 0. I've got like this 10 to the negative 4 displacement up here. And now look at what's going to happen. I'm going to start moving this slider across. And you notice that the velocity is starting to increase. It's going up, going up, going up. Velocity is still climbing and climbing. So this is where it's still rolling down the track. And now I want you to look at this. We should be able to get this last velocity, 930, looks like it was 930. We should be able to get like this last velocity right before it hit. So we can see that velocity. And now I want to do something. Watch this. I want to keep moving over. And now this is pretty interesting. I can't get it dead on the 0, but look at this. There is my last velocity before it stopped going forward. And look at my next velocity. Now it's a negative velocity. So we can kind of get this idea of exactly when the cart hit the end stop. So like my cart traveled 88 centimeters before it hit. And we can also get a maximum acceleration. So we can get a lot of data from this. And now let's keep going down. And so here is my rebound velocity down here. So if you can tell, I lost a little bit of velocity in the collision. Not a whole lot, but I did lose a little. And so now I can see where I'm kind of on the rebound. And now look at this. I've got a negative velocity now because the cart's going in the opposite direction. But look at the magnitude of that velocity. If you really look at it, what's happening to it? The velocity is going down, 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 down. And I guess what would be interesting is this. Can you figure out, and this is part of your lab, can you figure out where this is at? So in relation of the cart rolling down the track and bouncing and going, get-dong, 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 where is this at? And so now we can see now the cart's going positive again. And it's going down, 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 back. And here we go, collision time. And it looks like there's our speed before it hit the second time. And for a moment, the cart actually, there really was a 0 for a moment in there. And then we can see where we rebounded and we started going back up the track again. And again, there's kind of an interesting thing. What happens to the velocity of that cart at that instant? Now, I want you to kind of look at the accelerations real quick. So let's look at this acceleration graph. I'm going to do something. I'm going to, well, one, I need to get on the right graph. So let's click on this acceleration graph, and I'm going to do something. I'm going to put a little box, and let's get rid of that. Matter of fact, get rid of that thing, and let's do something. Let's get, excuse me, some statistics up here. So it looks like my average acceleration is about 535 for that first section. Now this is interesting. Let's put it on this section as well, about 0.60. Now in theory, take a wild guess what the acceleration is, 626. Now I'm saying 5, roughly 0.6. 0.626 again. Let's do something, shrink this down. 0.535. In theory, in the perfect world, we should have actually roughly had the same acceleration for every single section. Because you should think each time, what is it that brings the cart down the track? And that's gravity. So obviously, if I could have tilted my track enough, we could have actually got a 9.8 on this. But then again, I would have dropped the cart on the floor. So anyway, this gave you a sample of data if you needed it. So anyway, thanks for watching, guys. And I'll show some pictures of some more data after this in case you need it. But bye.